Okay, on to question 13. So let's find an expression for the gradient of the line joining point A to point B. Okay, so standard, if you were to think about it, we've got a line, point A and point B. Usually we're given coordinates, but for a bit of fun, we've been given algebra instead. Okay, but that shouldn't deter us. Everyone's quite comfortable. If this was 10 and 13, we don't know what to do. Okay, the gradient of a line, pardon me, it's just the difference in the y's divided by the difference in the x's. Okay, y2 minus y1 divided by x2 minus x1. Okay, so everyone should be quite comfortable with that. Okay, now just to give me some space, I'm just gonna rub some of that out. Okay, I'm just gonna start up here. Okay, so let's call this our second point. We'll call this our first point. Okay, so y2 4p squared minus y1, which would be 9, divided by 4p minus 6. Now, what's in the simplest form? Okay, now there's two things to think about here. If they want us to simplify this, something on the top is going to have to look like something on the bottom. So it's always worth having a look at the bottom and saying, well, how can I simplify this? The only way I can simplify it is say 2p minus 3. Just take out 2 as a common factor. Okay? So if they want us to simplify it, they're going to want us to get rid of the 2 or this. Okay? That's a really good idea to start off with. So it gives us a clue as to what this might break down to. Now this, we can see there aren't any p's. Okay? So if there aren't any p terms, it means when we're multiplying it out, so say we've got our little table, it means that this and this section would cancel out, okay? So just to show what I mean. How do I explain that? So yeah, we want this term cancel out. So we've got a 9, okay? So we've got minus 9. We know we're going to have a minus 3 and a plus 3 right away because we know minus 3 times 3 gives us minus 9. Okay. We also get 4p squared. So how did we get 4p squared in here? We're going to have 2p in here and 2p in here. Okay. So if we do that, we end up with minus 6p over here. And if we keep this as plus, that will give us a 6p in here. And then they'll cancel out. Okay, that's what I was meaning. So we've got the plus and the minus. Okay. So say we've got the same terms, but we've just got one side different. Okay, 2p minus 3 and 2p plus 3. And you'll notice that that's the same as that one. So again, if you look at the bottom, it gives you a clue for what you might get on the top. Okay, so to try and factorize this, think of your table, think of what two numbers are going to give me 9. It's going to have to be a 3 and 3 minus 9, well one's going to be minus. There's no p term, so I know these two are going to cancel out, which means I'm going to have a something plus something and a something minus something. Okay, 2p minus 3s are going to cancel out, and you'll just be left with 2p plus 3 divided by 2. Okay, so marks for that one. First of all, getting this through your correct substitution, that's fantastic. Second bit would be your factorization, and then the third part would be simplification. Okay, so that should have been very straightforward. This is a little bit trickier, but like I said, if you start breaking that one down, you can think, okay, well, what they're gonna want me to cancel stuff out. So maybe the top's going to look at the bottom, and that gives you a little clue. Okay, and the fact there's no p's in there is a big clue. Okay, these have to cancel out, or add together to cancel out. Okay, good stuff. How's that? Solve the equation. This is brilliant. I mean, this is about as easy as your calculator questions get. But just because we're starting to use sine and cos, people panic. But this should be something that's actually really in the bag. Okay, if I'd said to somebody, 5a plus 2 equals 1, okay, everyone could do it. They'd say, okay, well, 5a is going to be equal to 1 minus 2, so that's minus 1, and then a is going to be equal to minus a fifth. because we're dividing by 5. Everyone can do that, but suddenly you put costs in there and it confuses people. Okay, now if we just say, well, that was the exact same moves except costs. Okay, so costs of x is actually equal to minus a fifth. It's the exact same steps we would do. We would do 1 minus 2, then divide by 5. Okay, so right away, without doing anything particularly complicated, that's first year work, we've got a good way along the question. And now to get x, what we need to do is cost to the minus 1 of, this is where there's a little bit of intelligence involved. We need to know that we're just going to do a fifth, first of all. Okay, we don't want to do the negative number in there because our calculator will spit out a very strange number. Okay, so we're going to do cost to a fifth. Okay, so cost to the positive a fifth is going to give us 78. We'll just do the 1 decimal place 0.5 degrees. Okay. Now, the reason I like to keep it positive is because of our quadrants. Okay. Now remember it as all smokers take cancer. Some people remember it as other stuff. I can't actually think of some other acronyms, but yeah, I always remember it as that. Okay. Cats, I don't know, but yeah, all smokers take cancer. So what this is saying is that in the first quadrant, okay, everything is positive, right? In fact, I'll undo that, right? In the second quadrant, sine is positive, tan is positive, and cos is positive. Now we've got cos x of minus a fifth, so we're looking for when cos is negative. So everything's positive here, and cos is positive here. So we're looking at quadrants 2 and quadrants 3. Okay. So the angle we're looking for is going to be this angle here. Okay. To get that, we're going to do 180 minus the 78. Okay. So in quadrant 2, we're going to do 180 minus 78.5. And then in quadrant 3, that would be the angle we're looking for all the way around there. We're going to do 180 plus 78.5. Okay. So that's going to be 101.5 degrees. Yep. This is going to be 258.4 degrees, or 0.5 degrees. That's not very clear, is it? I do apologise. When I get to the bottom of the screen, the pen becomes slightly annoying. So yeah, 258.5 degrees. Okay, so that is the question. Okay, so 3 marks. Okay, where do we get our 3 marks for? Cos x is equal to minus a fifth. That's our first mark. Okay, slightly bigger pen. Oof, there we go. And then we've got our 2 quadrant values. So there's not a lot of scope. Yeah, that's where the marks are going. Like I said, this is the only bit that requires a little bit of knowledge. You could put that into a calculator. I think it makes life much more confusing. I think it's good to always put your positive number in and then say, well, what am I looking for? I'm looking for when cost is negative, and then adjusting. I think when you've got a negative number in here, your calculator probably would have spat that number out, and then you would have had to work out the extra to get to here. I just think it's worth it. Okay. And the reason we did both these quadrants is because we've got limits up to 360. Okay. Sometimes it can ask for more, sometimes it asks for less. If it was less than 180, we would have shown that. If it was up to 720, we would have added on, we've done this for another 360, okay? So we're adding another 360, right? So yeah, it doesn't usually do that. Usually it's up to 360 or 180, okay? So remember in our all smokers take cancer, what it means, and just, if you've got a negative in here, do the positive. That's a big part, okay? Good stuff.